So we are going to present you how we discovered green IT thanks to the Sustainable Digital Challenge proposed by Apidays and what followed from it. We will present you the context of the approach, your discoveries and action undertaken during the challenge, and after the challenge. To begin, so who are we? We are agents of INSEE, the French National Institute of Statistics and Economic Studies, which is a Directorate General of the Ministry for the Economy and Finance. INSEE's mission is to collect, analyze and disseminate information on the French economy and society across the entire French territory. INSEE operates with total professional independence. And we presented a team of the Hermès approach. Hermès for référentiel de métadonnées statistiques. What is Hermès? Hermès is a project for statistical metadata like geographical codes such as the list of common nomenclature, etc., throughout the life cycle of data. Donc, Hermès consists of a repository in several databases, management interfaces, search and consultation services, APIs, for client application. So we presented multidisciplinary teams, dev, ops, product owner, strategic decision maker. And in Green IT, we started from scratch. This aspect of the design and life of an application had never been tackled before at INSEE. We knew nothing about it, no tools, no principle, no involvement, nothing. Your objectives were very simple: to learn and then pass on what we had learned within our institute. But why our motivation? Because one feels concerned by the subject, because one likes challenges, because one likes refactoring code, because one is curious, because my life is involved, my wife, because it goes hand in hand with the BGS.
So what is the BGS? Next, BGS. It's a. I don't know. It's French, so it means bilan d'émission des gaz à effet de serre. So what is it? So it's an acronym from Greenhouse Gas Emissions Balance. Okay, it's part of a global plan to get neutral carbon in France in 2050. So it's in progress action in all French authorities. So the part of that in INSEE was to start first in the first step to measure all emissions. So the first measure that was done this year in 2022 was based on year 2019. So that was the first step we did. Later we will, in next steps, we will try to reduce these emissions. And what we notice first is that it is very difficult to measure. We are going to see that later. That we took numerous difficulties in measurement. Yes, but INSEE first is better to measure ages, wages, salaries, etc., but not kilowatt hours. Okay, so a few figures to illustrate. Okay, so the total BGS for INSEE, so the total emissions for the year 2019 is more than 15,000 tons. Okay, here I don't say, but we only focus on so greenhouse gas emissions, only this point. Okay, so the total for all INSEE activities is so more than 15,000 tons. And here you see for only for the IT, it is 1,200. So you see the proportion. So to illustrate what the IT, what there is under the IT emission, there are more than 5,000 agents who use the INSEE IT. There are about 42 million visitors a year also, which contribute to make these emissions. And these UJAs are concentrated into only 3 websites, which represent more than 90% of all emissions. We notice that the API, which are the INSEE API, which are used, represent less than 1% of emissions. So it may be explicated by a less use of our APIs, maybe also because APIs are greener, or maybe also because we have difficulty to well measure the real emissions. Also to divide the emission by sector, by applications. Here you can notice here for network, it's only 1%, which is not you find frequently in analysis. Okay. The challenge organization.
Yes. A quick reminder of what the challenges is. Donc, it's raises awareness of green IT. We are accompanied by a mentor through the process. Free workshop allows us to tackle various topics on green IT. During this, there is a plenary presentation, theory, tools, group work, testing, reflection, and then exchanges with the other groups. The time covered were product and design, archi and infra, and code. And for the challenge side, there is a 3-minute final speech on what we did during these 3 months of challenge, and we won the jury prize. A quick overview of the agenda. So what did we learn and what actions did we implement during this challenge? Then we, well, there was already a lot of brainstorming. We call that we were starting from scratch, and so a lot of ideas and observations emerged when we were thinking about our practices. Then we discovered analysis tools to help us measure our green IT performance, as green IT is not a preoccupation in the design of our application. We did not expect to have a nice result. We audited pages of a metadata query application with the plugins we were presented with, Lighthouse and Green IT. So here is what we got, an echo index of F with the Green IT plugin, with a nice start by good practice. Lightout is more completed. We can see that it also gives us indication on accessibility, for example, where we still better. So we summarized our analysis, and our main pitfalls were as follows. Donc, little use of the front-end cache. We systematically call the back. Some resources are not comprised. Some inline CSS, no printing CSS, some duplicating requests, large cookies, especially for authentication, and several cookies per pages. And after some simple correction, we have a better index, F2D, E2D, D2C. So
the API. Well, yes, we are. So after the front, we are at the Apidays. So we are going to speak about APIs a little. That is the API where we made some improvement. So there is a portal at this URL which gives a few APIs of INSEE, external APIs for external clients. So the Hermes API, which give metadata, is one of these APIs, and everyone can request it and find, for example, the list of all communes, all towns in France. There are also other APIs, all cities in France. There are also other APIs which give access to other data. This data generally can be found in the website, downloading files, and what we think is mainly people go to the website and download the file, and they don't use a lot the APIs. Okay, so we think about how to improve metadata API. For example, we focus on the endpoint get commune, which means get all the cities. It's a big data API, since in France there are about 36,000 cities. So it's the request return a big amount of data. And this endpoint was very used, in particular by internal application which needs this data. First, so to improve it, we use application metrics to find which improvement to do, because we haven't more tool to analyze the back, and we looked at slow request and found that there was a bad green IT practice, I can say, because data which were frequently used, that is to say the cities, were stored locally and were requested were requested at each time. So we decided to use a cache on the server side. It's my personal thing is we could go further. Finally, is this endpoint really necessary? Finally, internally, application which use this endpoint before every treatment request to find all the cities, and then they use this information to make the treatment. But at each treatment, they don't need all the cities. They need only a few one. And finally, we can imagine that they request the metadata API every time they got a new city they don't know, to verify that the city exists, etc., etc. But I think it's another usage, another architecture which will be greener, but it's also another way to think with event-driven architecture. That's a point where we don't choose actually. Okay, a bit 1 minute for technical. Yes, so you can see here the before the refactor, before the changement. So in a few minutes, the use of the endpoint get communes generate many. So all the brown it is all the brown area. It generated many requests under the database. It's a HTTP request because the database is a RDF database. Okay, and so because the data weren't cached, and after the analysis, data are cached, and we economized HTTP request. So what we can notice also, we didn't see impact on metrics for the server. The CPU, the RAM stay about the same, but we imagine that it is better. It consumes less power to get the data once and not repeat a request. Okay. 1 minute to finish. After the challenge, what we have ever done. So we follow training course about Green IT because it is interesting, and to go further in reflection. We start internal education to motivate team for BCAT's application to improve their footprint, reduce that footprint. And we try to deliver a message to improve conception of application. And so it's only the start, and we have a lot of dedicated means. So we try to improve as we can. Yes, we plan to raising awareness of the business side to improve usage and don't make unused feature. We would like to make static code analyze to find bad practice. And also on the laptop agent side, we would like to improve the use of laptop of INSEE collaborators. For example, give them to switch off the laptop the weekend. So a special thank, and after it's finished, special thank to the challenge organization, our colleague, and our mentor Michael Fine, who learned us a lot of things. Thank you very much.
Do we have some questions? Yes, we do.
Hello. Yeah, I was just wondering, so you have a lot of data, I guess, and I was wondering if you were able to calculate if, like, the impact, the CO2 emissions, they are more due to the storage, like running running the hard drives and whatever, or actually the CPU, so the APIs and the consumption of that data. Like, what do you know? Like, what's maybe the the percentage roughly of each side? Because you have so much
Okay.
data. I wonder.
That's a good question, and that's why what I said that we had great difficulties for measurement, and so I think the measurement of total IT consumption of backend was easy because at this time we had only one data center with 2 shelters, so it's easy to measure total consumption. But inside the data center, I think it's impossible for the moment to distinguish between usages between apps and all. And what we think, we saw best practice, and what we think we should improve our data, our strategy for data conservation, for data saving, storage, and so archive data or delete data when they are not used.
Okay, thank you.
One last question. Actually, I've got one. Sorry. When we see the carbon footprint, obviously the hardware, both for internal and external users, I believe external users are the collaborators that do like the research study, etc., etc. Is it like les collaborateurs externes, c'est ça? Okay. No.
Okay, external users are all the people who visit INSEE website or people who answer INSEE survey on INSEE data sites.
And my question was like the big chunk is obviously the hardware and equipment for the user. If I understood right the pie chart, like so it was the carbon footprint of the hardware.
The hardware,
okay.
yes.
And did you like partner with EcoInfo from the CNRS body or whatever to get like laptop on a longer lifespan, or do you know like if the more IT department regarding the equipment of users that they started to do things like to reduce this carbon footprint also on the hardware side?
No, I don't think so. About users like CNRS, I don't think so. We don't have maîtrise.
No. My point was that at CNRS, they recently completely reworked the call for tender, so like the yearly call for tender, and they now raise the bar crazy. Like they demand 7 years warranty on the laptop and that kind of stuff. And it's such a big market, like the research institutes, so that actually some providers started to play the game. It's a game changer to have such a massive public service pushing for hardware on a longer lifespan. And I was wondering if INSEE could like kind join forces.
So I know we didn't do that, and it's a chance that it's a chance for us that the measure was on 2019 because in 2020 with confinement we INSEE bought a lot of new laptops because people had to work at home, and before they wasn't equipped, and so it wasn't a good year for INSEE mission.
Well, thanks a lot, both of you. That was very interesting. Congratulations for the prize. You won. Woohoo!
Thank you very much.
And